paper for you to.
Good evening, everyone.
Hi, Asia. How are you?
Hi, sir. Doing well.
Okay. I am. I'm recovering from the flu, and I went somewhere today and got wet in the rain. Oh my goodness! I feel worse than when I was catching the flu. Aye, aye, aye. But anyhow, Michael not feeling well himself, so I don't expect him to turn up today. Is Carol coming here today?
Not sure, sir.
Evening, sir. I can message her and ask her.
Oh,
Oh,
you got
here, you know.
you
Yeah,
don't need to.
yeah, I realize.
Good afternoon.
Good evening.
Good night. Good night, sir.
Mhm. All right, so I was saying to the class before you joined, Carl, that I'm just recovering from the flu. I was feeling really, really good. Went somewhere today and the rain caught me. And by the time I was supposed to run to the car for the umbrella, I got wet. And I don't know how it happened so quickly. Feel awful. But anyhow, let me see what I can do with you. But I know I have some stuff for you to do on your own. Um, as promised, I'm moving into units 2, 3, 4 now. I don't know which of them I'm going to be doing first, but um, just checking. Have you all received your exam results from last semester?
Yes, yes, sir.
Okay. All right. All right. So based on how I'm feeling, I think I should do this way. I'm going to give you an overview. There are three of you here. I'm going to give you an overview of 3 areas. And then I'm going to ask you to use this time. I'm going to stay here, use this time. I'm going to ask you to research a question each. And then we're going to come back and present it. And what it is that you have researched. I'm going to answer to put this in a Microsoft Word document. Then what I'm going to do is to combine, well, not necessarily combine, what we'll do is share the information. Mike is out, he's not well. He will get an opportunity to do the same. And while it is that you are, I want you to present on your findings. So each of you will do that bit of in-class research. I'll give you some time, then we're going to come back and then we're going to present on your areas. And then we're going to share the information that we have presented. So while you're doing your research, just whatever you're doing, copy and paste in, just do that in a Word document so that it can be shared with your team members so that they can have copies of it. So we're going to be looking at the hydrosphere, the characteristics and the chemical processes. I'm not planning on spending quite a bit of time here. So one of the things I want to look at 3 areas today to explain the role of the hydraulic cycle in the natural chemistry of the earth. And in particular, I want to look at the importance of maintaining equilibrium in the cycle. And then also want to look at to account for the sources, types of dissolved substances in natural water. And then in particular, we want to look at the nature and sources of these dissolved substances. And then another person will look at formation of acid rain and its impacts on the environment, such as building, water quality, aquatic life in natural waters. So that will lead us up to a lovely discussion as we move into preparing us for pollution, and in particular water pollution. Then we can look at different sources of water pollution. I have already spoken to you about some of those in an overview. We can look at some water quality standards and indicators, and can look at some determinants of water quality and oxygen content. Then some VDO and CDO in relation to the water quality standards. So some of those things are very important for us to understand. Fecal coliform count, we need to look at those. We need to look at some suspended solids, total nitrogen, total phosphorus, water sources. So I'm going to importantly, whoever's going to be doing the acid rain, chemical reactions are needed for those. And when you look at those chemical reactions, I need written balance equations to explain those reactions or the reactions that take place. And I also want you to be able to tell me, what is this acid rain? How is it formed? What can be done? Or can we mitigate? So all of these things that I want you to look at. All right. I'm actually putting these now into it that I will share with all of you. That I want to look at for me. Remember, you're going to stay here, do it here, because we're going to come up at some point in time to present. And then for subsequent classes, we can improve on the research findings. Have some one or two little handouts that I want to go through with you. But I won't do that just yet. I'll have the effects first. Hmm. See the screen? Guys, are you seeing the screen?
Yes, sir.
Yes, sir.
Alright. I'm going to give you an option. Look at it. And I want one each of you to select one of those questions. Mhm. Who is going for what?
Sir, I'll do one.
You're the one? Okay.
Sir,
Yeah.
I'll do number 3.
Can you start for me, please? It's now 7:30. I'm going to give you about 45 minutes to do the research. I'll check in on you in 45 minutes time to see how far you are, but I want you to do as much as you possibly can, because we're going to be sharing this information among ourselves. So I know you guys are final year students, you guys can do this. One of the things that I was studying and in my Caribbean geology class, the lecturer will come and give us handouts to read, and we have to make some stuff and then we'll present. So it's nothing strange what it is that I'm doing. So I'm going to ask you to just use this time, go through the stuff to read on it, which is that you want to copy pictures to emphasize the point that we are reading and explaining. We're going to be doing a presentation on it today. I'll give you about maybe 10 minutes to do the presentation. I will collect copies of this as well. And so we can fine tune, so we can have it to do our own preparations. Is my, am I clear with what it is that we're supposed to be doing?
Yes, sir.
It's about 7:30. I'll check in on you in about 45 minutes. And I'll end this survey, I'll give you about 45 minutes to get some work done up, all right? Sure. Let me see. You feel as if you can
Good,
some
good evening, sir.
you feel like you can do some work, or you just want to, because what I give them to do is some work, you know. How you feel?
Yeah, man, we do some work, man.
Is it time to listen to them? Do that vision. Thank you. So I'm going to ask you to look at to discuss the determinants of water quality and oxygen content. We're going to do our research about 45 minutes long. We're going to do the research, and then we're going to come back and just present. And then I will just do some fine tuning with what is going to happen. What I want is whatever we're presenting, we're going to be sharing with our classmates. Whatever document that we're doing, I would suggest that we can copy and paste within the Microsoft Word document so that we can share the information and that will become the basis for which we are going to be used in our own preparations. So I want to look at the determinants of water quality and oxygen content. And I also want to explain the concept of BOD and COD in relation to water quality standards. All right, so it's really not difficult things that you can do in a period of time. So if you finish it before the 45 minutes, what I want you to do is to, plan your presentation, how it is that you're going to present it. I'll give you about 45 45. I'll give about 10 minutes each. 30, 45, and it goes to 8:15, 8:15, 20, 30, 40, 50, 8:15 and 10. Yeah. So if we finish 45 minutes from now, it's going to be 8:15, and with a 10 minutes presentation each, 8:15 plus 40 is 8:55. Yeah, that should be able to work. All right, start from it, please.
Okay, sir, no problem.
Sir,
PowerPoint presentation, right?
You don't even have to do a PowerPoint, to be honest. That may eat up some of the time. If you finish the thing first and can do it in PowerPoint, that's sure. But if you can do it in a Microsoft Word document where you copy the information and you have the stuff and you can present it to explain, however you make it, however you can make this well. As a matter of fact, I may even put a grade to it. Maybe a 5%. But
Okay,
we'll
sir.
see. I will let you know. So just do a good job, a good enough job on the matter. Sorry, Paz, you're coming in.
no, I was asking if it's called the hydrological cycle or the hydrologic cycle.
The hydrologic cycle or the hydrological cycle, same difference.
Oh, it don't matter. Okay.
Right. So it's a hydrologic cycle. Yeah. All right.
Mm.
Hey guys, how we stay? Are we okay? Finding the information?
Yes, sir.
Yes, sir. We're not finished, but we're okay.
All right, another 20 minutes.
Yes, sir.
Yes, sir. That good.
All right, cool. All right. How we stay? Are we about ready or ready? Who is ready?
Sir, I'm still not quite ready as yet.
Okay. Anybody else ready?
I can go.
Okay. Pass, how you stay? Asia?
I just stepped away from my laptop and I heard you. I just finished.
Okay. Asia, how you stay?
Finish up the last question, sir.
All right, cool. All right. So, all right, Mikey, you said that you can go first. Um, let me give you some time. I want the rest of you to listen. Mikey, let me give you 10 minutes, Mikey, and you go ahead. So you have to discuss the determinants of water quality and oxygen content, and you're also to explain the concept of BOD and COD in relation to water quality standards. Go ahead for me, please. Your 10 minutes starts now.
Okay, sir. All right. So good evening again. Good night now. All right. So water quality and oxygen content in relation to it's basically a measure that is used to judge by the standard. It's used to judge the quality of water for different ecosystem or human usage. And the parameters that are used are basically the physical, chemical, and biological factors to basically to be used as determinants for water quality and also for oxygen content in water. So for water quality, your physical determinants would be your temperature, your turbidity, your color, your odor. These are things that, if you want to refer them, you could say you're able to feel, to see, and to smell. You're using up those senses. And with temperature, higher temperature actually reduces the amount of dissolved oxygen that is there in dissolved oxygen levels, and it affects aquatic organisms, the metabolism, how they function. The turbidity is basically your suspended particles, such as your silty clay, any organic matter that may be floating around in the water, and it affects the water clarity. So you will be able to see through that block of water, and the amount of sunlight that can penetrate to allow plants in the benthic zone to photosynthesize. And the color and the odor stem from different pollutants that, whether organic or chemical contamination. The odor indicates those type of pollution. The chemical parameters or determinants are basically your pH. Water, normally pure water has a pH of 7, but the range for aquatic life form and human activities is normally between 6.5 to 8.5. The dissolved oxygen is essential, as this is how aquatic life survive. They need the oxygen to survive. And low levels indicate polluted water. Your excess nitrogen, your and phosphate, those are excess nutrients. Those are also chemical determinants. Your chemical oxygen demand and your biochemical oxygen demands are also indicators. Once those are high, indicates that your water is heavily polluted, and of course, the heavy metals that stems from your industrial activities. Those also indicate are chemical determinants. Now, your biological determinants are your bacterial count, your algae, your protozoas, those are also, they determine whether your water is clean or not so clean, but it really indicates level of pollution based on the algae bloom, which is called eutrophication. Now, your oxygen content in water is more than likely, it is the oxygen level in water that is crucial for aquatic life, and it's mainly influenced by natural factors such as atmospheric diffusion, that is where oxygen enters the water, and this is basically the water moving, like river flowing, and it goes over those rapids, and oxygen is introduced. And also photosynthesis by aquatic plants, which they remove the carbon dioxide and create and give oxygen off as a byproduct. The temperature, colder water holds more oxygen, and that is simply because as the water gets colder, the molecules start to slow down, and you have that lattice structure start to form, which creates space. And in doing so, oxygen, it can hold more oxygen molecules. However, high salinity reduces the amount of oxygen that the water can hold, and it's through a process known as salting out effect. That is simple, where the salt ions is added. The salt ions attract more water molecules, and it kind of condenses it. It's like the opposite of cooling the water to allow more oxygen to enter. So when that happens, there's not enough space for the water molecules to allow for more oxygen to enter. And your human activity is your introduction of sewage and wastewater, which increase by BOD, and it depletes oxygen. And your industrial discharge, which releases heavy metals, and your agriculture runoff, which is your fertilizer, your pesticides being released. Now, when it comes to biochemical oxygen demand in water, it is basically a key parameter that is used to determine the amount of dissolved oxygen that a microorganism used to break down organic matter over a period of time, normally 5 days at about 20 degrees Celsius. And the measurement for that is milligram of oxygen per liter. And the importance of the BOD in water quality is to indicate the amount, the organic pollutants. So a high BOD suggests that you have a lot of biodegradable organic matter, and you have a high bacterial flora, which is actually breaking down that, which eventually gives you oxygen. It also speaks to oxygen depletion. Excess BOD can also result in oxygen depletion levels and make it difficult for aquatic life to survive, and that tends to happen through eutrophication. Regulatory standards, it's used by the government agency to limit the amount of wastewater that can be entered or discharged in a water system or water body to prevent water pollution. In terms of chemical oxygen demand, it is similar to BOD. However, the difference is that the chemical oxygen demand, it speaks to all chemical oxidized organisms or inorganic matter in the water, and it's expressed in milligrams of oxygen per liter of water. And it's a good indicator of pollutants because it takes into account every single, again, oxidized organic and inorganic matter. It is used to compare BOD, where the BOD measures the biological process, while the COD, it includes every single chemical oxidation substance, which is more than likely quicker and more comprehensive in measuring pollution. And it also has regulatory limits, different body of water and wastewater discharge regulation will actually set limits to the amount of COD to prevent excess pollution. For example, treated wastewater should have like about 50 milligrams per liter before it's discharged in any water body. And in concluding, maintaining good water quality and aquatic oxygen level is essential for aquatic ecosystem and human health. And also effective water management practice and pollution control in general regulates compliance and helps sustain water resources and ensure ecological balance, which is what we strive to do as environmentalists. Thank you.
Thank you very much, Mikey. Good job. Excellent, excellent work. Let's hope now that you can, I know that you've read this stuff. Let's hope now that you can internalize what it is that you've read.
Yes, sir. Sir, it's actually this model right now, like literally. Yeah.
Right. So it is when we're talking about pollution and water quality, it is important for us to test our BOD and our COD, so it is that we can have an idea as to how severe pollutants we have, because it's very important. And one of the things that he didn't speak about just yet, and that we'll talk about sometime later, would be the sources of these pollutants in our water system, fecal matter, or plastics, and the likes. You know, as I explained to you some time ago, that when hoteliers empty their effluents into the ocean because they want to save money, when the environmentalists or people who are working with the National Water Resources Authority pretty much going to test the water quality, they have to test the BOD and the COD. They compare those, and if it is that the fecal matter is of a certain percentage, or E. coli or F. coli of a certain percentage, they can say, okay, this water is polluted, you know, and give some cautions and try to find the source. And you know, they will say, okay, this river or this beach is now closed by the authorities because it now poses a threat to human health. So what it is that you're doing is very important. Not only that you can go to NSWMA, that you can teach, that you can become an occupational health specialist, but you can also now go and work in water resources management to advise those persons if it is that you are, you know, whatever is happening. Case in point, final comment, and then I'll ask us to go, is, you know, especially when you're doing like public swimming pools, persons from the National Water Resources Authority are mandated to go to these public pools. So like the National Stadium, they have to go and do their water test to make sure that the water quality is maintained. Because if you have traces of different matter in the water quality, it then becomes unsafe, and the national arena now will have to go, and the National Aquatic Center, sorry, will have to go and treat their water. The place will have to be closed. And the truth of the matter is they don't necessarily have to drain the pool. They can chlorinate, they can add different chemicals to to kill the growth of the algae falls to the bottom of the pool, it becomes like a sludge. They'd have to now use vacuums to remove the algae that falls to the bottom of it. So it is an interesting area. The National Water Commission again, will go and do that. People who store water, and oh Lord, one of my pet peeves, and I just going to leave it there, and I want you guys to go and research it. One of my pet peeves, why I am particularly afraid of having water from different places, is, hold on a minute, is people like and some of you are not going to believe me, but people like Lasco. Do you know that when they are doing their bottled water, that the water that they get is water from a well? Anybody knew that?
No, sir.
No, Mitch.
Yeah,
Right?
yeah, man.
No,
Them get
sir.
not all of them get from spring.
It's not all
Majority of them are
from-
well. Yeah, man, well
Absolutely.
water.
So it's well water that you are having, and what it is that they do, they treat it with things like ozone. They remove all the minerals from it and then add artificial minerals, right? So when you drink these bottled water, it's just purified water that you're drinking. What does purified water add to your system? Sometimes when you taste the water is a little salty because too much minerals are added to the water, and it becomes a little bit salty. So lots of people don't know, but if you are in this field, and I'm saying environmental field, you will know exactly what happens. It is water that is stored from a well, and sometimes you know what happens in a well. You may have rodents coming and dropping in the well. You may have a stray post drop down at the well, and him did it, and him going to, whatever the situation is, the water is extracted, the water is treated, minerals are taken from it, the water is purified, ozone as one of the purification agents is passed through the water, and the water is then fit to be used. We will speak about potable water. We'll speak about all of those stuff. But yeah, the things that we are consuming, sometimes we don't even know the source of it. But Paz, go ahead, please. We're coming back to this because this is just a start of it. Go ahead, Paz.
All right, should I share screen
You can go
or
right ahead.
just read?
Go right ahead. Let me stop sharing and then now. Let me stop sharing. Go ahead, sir.
All right, so the hydrologic cycle, also known as the water cycle, plays a vital role in the natural chemistry of the Earth. The hydrologic cycle not only transports water throughout the atmosphere, lithosphere, and hydrosphere, but also transports dissolved substances. Examples of these substances include minerals, gases, and organic matter. These substances are dissolved by water, which is considered to be a universal solvent. These dissolved substances transport nutrients such as nitrogen and phosphorus, as well as dissolved ions such as calcium, magnesium, and sulfate throughout the different spheres. With that being said, if the hydrologic cycle's role was to be disturbed, it would disrupt the natural flow of water, minerals, gases, and organic matter, which is crucial for supporting life. In other words, the natural chemical processes would become stationary or stagnant, creating imbalances in nutrient availability and the composition of different gases throughout the spheres affecting lives. See if I can. All right, furthermore, the different phases throughout the water cycle have important roles in relation to chemistry. For example, when water evaporates from the earth and transitions into water vapor, it not only helps to regulate the earth's temperature, but also contributes to the removal of airborne pollutants, including sulfur dioxide and nitrogen oxides, which could contribute to acid rain. Two other processes throughout the hydrologic cycle that contribute to gas exchange throughout the atmosphere, hydrosphere, and lithosphere are evaporation and precipitation. Runoff is another vital component of the water cycle as it transports dissolved salts and minerals into waterways, such as rivers and streams, into large water bodies such as the sea or ocean, impacting salinity. Groundwater flow also helps pH levels maintain aquifer quality. So the aquifer, I explained it, underground, it's an underground layer of water-bearing material and serves as a natural filtration system, removing contaminants and recharging water supply. Yeah, that's what I have. Hello?
Sorry, I'm there talking and I'm muted. Forgive me. I'm saying thank you very much, Paz. Based on the time, the ladies won't get an opportunity to present, but they will do that on Thursday, I believe it is. Yes, Thursday next class.
Yes,
And
sir, Thursday.
right, and I will give the gentlemen more time to go back and look at what it is that they've done. I know it's just a short time, but I will also send a little bit more so it is that we can beef up the stuff. Several things that you said, Paz, and it's very important. Now you concur one or two other points with that Michael made mention of as it relates to salinity. That's number one. And number two, you also spoke of the importance of the hydraulic cycle as it acts as a solvent. And this is why it's very important for me to have gone through the basic terminologies in chemistry so that when you're reading these things, you know what a solvent is versus a solute. The solvent is what is doing what? What is the solvent? What is the solvent? Come talk to me. Anybody remember
So
the solvent?
the solvent would be the water in this instance for the example.
Right. So in a general term, the
The
solvent is
diluter.
doing this right, is what
The
is doing the
dissolve-
dissolving, right.
Yeah.
Right. And the solute is what is being dissolved. Right.
Dissolve.
So in general form, the solvent is what is doing the dilution. And what is important is the solvent from the hydraulic cycle, which is water in this particular case. And once we talk about hydraulic cycle, we know that we're talking about water. Water. Is very important and very useful for dissolving sulfur dioxide and the nitrous acid, nitrogen oxide in the atmosphere. Now, those are major components of acid rain. I will, as I said before, I didn't give anybody the acid rain something to look at. I don't remember if I did, but anyhow, acid rain is one of those things that is very important. It's very, it will take a lot more conversation. Case in point, when I was at this place and then the rain came and I recognized that wash and we're just coming out of this, literally just stepping out of the flu phase, just stepping out. It shouldn't get wet. So I decided that I'm just gonna go and take shelter, and then the rain decided to come heavy and I was like, oh, why didn't I not go for the umbrella earlier? So I had to run for the umbrella and in the process, of course, got wet and then, the feeling that came on, thing and thing. But what was interesting is that I stood up under my umbrella and then I just exhaled. Why is my umbrella leaking? And I just stood up and just looked under the umbrella and then I remember what it is that I was gonna have in class. And then I think, I'm not sure if it was the same time that Mikey said something to me, and then I was saying that I was just thinking about the class, or something like that. But anyhow, acid rain, it's the buildup of this sulfur dioxide that is in the atmosphere and the hydraulic cycle, it dissolves it. Water is a solvent, it dissolves it. And you're gonna have a weak sulfurous acid that is formed. This acid, touch up on on our umbrellas and cause it to have holes, and it has an effect on buildings because those buildings that are made from limestone starts to shed, and the zinc sheets starts to rot because the acid corrodes the zinc sheet, and then the sun comes and burns it out. So you recognize that the zinc pretty much is just rotting, and then places start to leak. So it has a lot of effects. And we need to look at the sources. We won't tell you where the sources come from just yet, because this is just the first time we're getting into the hydraulic cycle. We don't talk about the lithosphere yet. We don't talk about the atmosphere. So even though we're looking at the hydraulic cycle here, there are several things that are coming out that you'll see again when we look at the other spheres. So it's very important, very, very important. How do we mitigate on the production of sulfur dioxide and nitrogen oxide in the atmosphere to reduce the acid rain? When we move into the atmosphere, we're going to have conversation about these chlorofluorocarbons, or the CFCs, and the effect that it has on, or they have on the ozone layer. So I am going to end here. But what I want you to do is to recognize the importance and how interesting a read these areas will give. And I'm saying to you, colleagues, students, I said colleagues just now, but I have no apologies in saying colleagues, because the truth of the matter is, at any point in time when you guys would have completed your studies, easy, you can come and join Team Excelsior or Team wherever, right there, and then you should be able, can be able, will be able to execute a duty as Unit 1 and Unit 2 environmental science teacher. You can become one of those persons who teach integrated science. So, I'm not in any way, shape, or form watering down what it is that you're doing. Finally, that what I'll talk about, I didn't remember this part of Paz's presentation. He spoke about the aquifers. Now, Jamaica has a good system in place where our aquifers are very clear, he spoke about it has a natural tendency to purify the water. What we call it is an attenuation property of the aquifer. What it does is, I did say it earlier, if a body gets into our aquifer, it is able to pull the bacteria from the water. It's able to pull the bacteria from the water. And why so? Because Jamaica is blessed with lots of limestones, and most of our limestones are surrounded by those aquifers. I don't know if any of you have been to Green Grotto Cave. I really am trying the idea for us to have a trip down
Yes, sir,
there.
I've been.
Yeah, man.
Same.
You've been there, Asia?
Sir, me go there when we little bit, and them I say we no for open my mouth over the back cave, cause the back them we do that
In a
anymore.
prep school.
I've never been there, sir.
Karen, trust me. It only takes you to make a teacher feel better. Honestly. I love it. Yeah, man. I am trying the idea that I may put one of those things in place, one of those visits, trips in place, so it is that we can go there and we can see geology, we can see environmental science in real life. You see water exposure that is very rich in calcium. You'll see precipitation of salts coming out of the water. Water that if you and I go in, we cannot survive in because of the contents of it. We're seeing things like you still have aquatic animals, fish that are swimming inside there. They will say to you, do not touch the water. We have active stalactites and stalagmites in Jamaica still, believe it or not. It is just surreal. The water quality is even purer from our piezometric level than the water quality when you turn on a tap in Guyana. I'm told, never been there, but I'm told from studies, when you turn the tap in Guyana to fill a glass and you look in the glass, you can literally see organisms
Yeah,
moving
bro.
around. Yeah,
Yeah, what?
brown. You see
That's
it.
the serious thing.
So they can't use the water to cook. They have to use purified water or bottled water to cook because the water is dirty. No, our piezometric level from our groundwater reserve or aquifers is pure. We can, if Jamaica goes into a crisis, we can drill down into our aquifers and the water from our aquifer can be had. And I'm going to call that potable water. So it gets interesting. It gets really interesting to see when people say that Jamaica is a blessed island, they just say it because it's colloquial. But maybe they don't understand the earth science of it, why it is that it is so blessed because of our groundwater reserve. We have as much groundwater reserve that can sustain us. All right. And as a result of that, you and I now will need to protect the environment so that we are protecting our groundwater. We can't go too far down because if we go too far down, we're going to disturb our groundwater reserve, right? So we have to be very careful. In order to access the groundwater, we have to actually drill down. So these are things that I want to read upon. Jamaica groundwater reserve, the aquifers, where we can find aquifers in Jamaica, where we can find aquifers in the Caribbean, and the whole stuff, because it makes life so much easier. And then we're moving into pollution, how it is that we pollute the hydrosphere. And the pollution of the hydrosphere is not just to put plastic bottles in the ocean. There are other things. Michael spoke about it in terms of those BODs and CODs. All right. We have fecal coliform levels. We have dissolved minerals, things like fertilizers that get leached into our rivers and streams, a buildup of sulfate ions inside here that we don't want. It kills aquatic plants and animals, right? And all of those are then channeled into our ocean, because if you talk about the hydrosphere, it flows into our oceans, and then now we're going to talk about things of, different things in order. So as I said before, the reading, it gets very interesting, and it's for us now to really understand and to make connections with what it is that we're reading. So I say to you, which is why I gave you this stuff to do today. The same thing that we do today, I want you to go back and look at it and Pastor Michael will come and say, boy, so I didn't mention this, but when I reread it, I recognize that I should have mentioned this, so forth and so on. So it is that we can get an in-depth knowledge of what is happening. It's a beautiful era to see how, forgive me, I don't know where you are spiritually, that God, in his beauty of creating this place called Earth, it's not by chance for me, because things are just adding up and one thing connects another. But he was the greatest and purest physicist and chemist and biologist and environmentalist and geographer, and I mean, things just happen. Things just connect, and you will see how the lithosphere and the hydrosphere and the asthenosphere and all of them different sphere just come together, and you find the interconnection, because what happens in the hydrosphere then runs into the ocean, and then it gets into the lithosphere, and then I spoke about it, the whole business of evaporation. And evaporation is very important, because all of those build up sulfur dioxide and nitrogen oxide will have to come down at some point in time. They come down and they get into our ocean, and they kill our aquatic plants and animals. So life is a cycle. So we need to know the cycle. We need to know the water cycle. So please go and study the water cycle in the meantime. We're on the hydrosphere. Study the water cycle. Everybody, study the water cycle again, come back and have a conversation on the water cycle. You need to be able to explain to me how the water cycle operates. All right. Thanks for coming out. You know, it's interesting. I don't know how many of you interest is spiked, but very interesting aspect of the studies that we bring. Thanks for coming out.
No problem, sir.
All right, sir. Thursday.
Okay,
cool.
sir.
I said get well soon.
Thank you, my love.